really what got me going was looking to Plato initially. And I saw him, as I do now see him, as a Pythagorean and Eleusinian initiate of the mysteries. I realized pretty early on he had to keep his mouth shut. He really couldn't even introduce the mathematical principles of music, but it now looks like the dialogues are actually coded with Pythagorean music. Jay Kennedy here at the University of Manchester essentially figured that out. But also his puzzles that he presented were intended to present the reader of his dialogues with the opportunity to retroduct, use novel reasoning, kind of the right hemispheric way of approaching logic. It's not deduction, it's not induction. So it's not a downward movement from premises, rather it's from the observations, particularly anomalous observations, to abduct a solution, as Einstein did with, for example, the black body radiation, photoelectric effect, and specific heats. Is a good example of abduction where everybody else was kind of ignoring them. But he put them in the pressure cooker here, and then through visualization and the kind of, intuitive leap, that's where, from my understanding, the relativity theory really, he grasped it and saw that that would be a solution to all three of those anomalies simultaneously. And you look at Kepler, you look at Bohm, you look at yourself, you look at you people looking at these puzzles and then getting these incredible hypotheses that where the universe, if you ask the right questions, my thinking is you'll get the answer. And the answer is quite simple, as you're pointing out. It's shockingly simple, and it's golden. But we kind of confound things, and we're not open to this. But some scientists, some thinkers who have more of an aesthetic approach to things and an open heart tend to see those things. So what I found Plato doing was presenting problems, puzzles, anomalies, apparent contradictions, to try to invoke or evoke, get the reader of the dialogues, like the member of the academy, to come up with a solution to the puzzle, whether it's doubling the cube or give me a hypothesis that explains this somewhat erratic motion of the heavens. Those are all attempts at that. And when you take the Timaeus and the Republic, you put those two together. In the Republic, the puzzles really, I've already mentioned, they revolve around the divided line and then the cave and trying to figure out what Plato was really up to, particularly the divided line. But in the Timaeus, which really was a borrowed work, some people even claim plagiarized from the works of the Pythagorean Timaeus, Plato, that's his cosmological account. And of course, you have the 5 regular solids. And 4 of them he would depict as being like the tetrahedron would be fire, and the cube would be the earth, and the icosahedron water, and the tetrahedron or the octahedron air. But and again, these are kind of mythic approaches. They're a mythology, but they have deep meaning. And so the 5th solid, which sometimes was looked at as the ether, was also the cosmos, and the 12 faces with the pentagons. But the odd thing was, he gives you the triangles to create the equilateral triangles, namely root 3, and he gives you the root 2, square root of 2, to get your square faces making up the cube, but he doesn't give you any triangle. He leaves it in fact, it's totally silent as to the construction of the dodecahedron. It is almost obvious by its absence. It should invoke in people, wait a minute, why is this that it's missing? Well, it's missing because the moment you try to figure that out, you have to move into the golden ratio. You're forced into understanding it. And of course, Hippasus, who did reveal the structure of the dodecahedron, which you brought up earlier, actually, he did lose his life. They put him in a boat. They sent him out to sea. If it weren't for him, we'd still probably be a bit in the dark. We'd be struggling, at least for a while. But that's what Plato was doing. So the Timaeus begins 1, 2, 3. But where, my dear Timaeus, is the fourth of those who were here yesterday with us? Well, what's happened is one of the people who were present the day before is now missing. He's become sick. But when you study Speusippus, the nephew of Plato who took over the academy when Plato died, and you look at his Pythagorean number writings, which we have fragments of, the 1 was represented by the equilateral triangle, all sides equal. The 2 was represented by root 2, the diagonal of a square. The 3 was root 3 when you bisect the equilateral triangle. And Plato gives us those, and the 1 is kind of in the background always, but the 4th is missing. How do you construct the pentagon to get your dodecahedron? They couldn't, and so again, it's absent conspicuously. So what Plato then says is these are the elements which we build the cosmos up through these solids. But anyone who can give us a more primitive element, a more perfect form, we will give the prize to. We will give the, what does he say? Not the crown, but the palm. We'll give the palm to, not as an enemy, but as a friend. Hint, hint, hint. He's asking you to abduct the solution to the dodecahedron. Then he says another thing extremely important. He says, because throughout the dialogues, there's this problem. You see it in the Parmenides, at 133 in the Parmenides, where it's called the worst difficulty argument. If you have something that's immaterial and something material, how can you bond them together? Hermes has already told us, as above, so below, and as below, so above. But Plato in the Timaeus says you need a third factor. And the third factor is a mean, but it's not arithmetic and it's not harmonic, it's geometric. And so the geometric mean becomes the key to Plato's system of bonding, again, kind of mythically, his intelligible with his sensible realm, and it lies at the level of dianoia, the intermediate realm, where the hints are, and it's obvious, that is occupied by the mathematicals, which are like the forms. They're perfect, but they're multiple. And they get infused into the sensible world because the mathematical realm and the sensible realm, mathematically, when you divide that thing and get 4 parts, they're equal. And those actually, in illumination, you see how they overlay. So the point is, Plato gave us the secret in terms of the geometric mean, and that's the only way you can get proportion immediately from a single ratio, an immediate cut. So in the Republic, take a line, even tells us to cut it unevenly. If you cut it in half, then the whole line is to either segment 2 to 1, and the 2 parts are going to be 1 to 1 in terms of ratios. And those are not equal. But if you golden cut it, the whole is to the longer in the same ratio as the longer is to the shorter. Or, if you prefer, the shorter is to the longer in the same ratio as the longer is to the whole. At Notre Dame, there was someone by the name of Sayer who presented a puzzle, and it's a brilliant problem or puzzle that I called the Sayer Challenge. It's Kenneth Sayer, a wonderful professor of philosophy and of Plato. And he wrote, "It is barely possible that Plato had the golden section or golden rectangle in mind when he constructed the divided line and thought of its unique aesthetic qualities as somehow reflecting the good as the ideal of beauty. The commentator convinced of this would have the formidable job on his hands of making a sense of the extended quality." And then he takes the divided line and you have the parts A, B, C, D. And he says, well, A is to B equals C is to D, and A plus B is to C plus D equals C plus D is to A plus B plus C plus D. In other words, he sets up this incredible kind of geometric proportion sequence, but it's simple. Because the moment you do a cut, and you do a golden cut, it all falls into place. It became the basis of my little golden section book. That's at the beginning of it. That is, for me, Plato's revelation that the golden section is the key, really, to the universe. Now, the other thing that I should probably say, and we'll make this fairly short, that is that it's interesting if you take and you consider biology, and you consider the Phyllotaxis that you mentioned earlier. Phyllo is leaf, taxis is arrangement. And the question is, how do leaves or buds, how do things spiral? How do they grow on a stem? Well, there's distichus at 180 degrees, like corn. There's whorled, where it goes at right angles in 4 directions. So you look at the top of the plant, and you see this beautiful fornus called whorled. But the majority of plants use spiral phyllotaxis, where the angle, that what's called the divergence angle or the genetic angle, approximates 137.5 degrees. Well, what's interesting is if you take 360 degrees in a circle and you golden cut it so that you have 2 segments, your segments are going to be 222.5 degrees and 137.5 degrees. Well, then we ask ourselves, well, why did they use measurement with yardsticks? And of course, we've gone metric. I'm not saying metric is bad, because I like the number 10 and multiples thereof, and the decad of the Pythagorean. But there seems to be a reason why they use 36 inches. So if you take a yardstick of 36 inches, you golden cut it, you're going to find that you have 22.25 inches, or 22.25 inches. And the other segment is going to be 13.75 inches, or 13.75 inches. So in essence, if you multiply times 10, the 36, 360 degrees, like a circle, here's your 137.5 degrees. This is your winding number of nature. And then it is to the 222.5 degrees, or 22.25 inches. You've got the same thing. And now here's the solution. Yes, when you do the golden cut, it is true that you're starting out with unity. That means your segments are going to have to be smaller than 1, and I agree. So you're going to have 0.6180339, then you're going to have 0.319, etc. You'll have it smaller. However, when you ask yourself what is the ratio of the whole to the longer part, it's going to be, now this becomes, if this now becomes unity or 1, this is 1.618 is to 1, as 1 is to 0.618. So what's happening is 1 becomes the geometric mean. It's maybe, I don't want to go out on the limb, but there is, the Neoplatonists taught the Christians the golden mean. They taught them about the Trinity. I'm not arguing for any Trinity, whether it's Brahma, Vishnu, or Shiva, but there is an interesting relationship. So this now is 1.618, and this becomes 0.618. The 1 has transferred itself into the middle member. So now another sense of 1. So 1 becomes the geometric mean between the lesser 0.618 and the greater 1.618. If you subtract 0.618 from 1.618, you get 1. If you multiply these two together, you come back to 1. Here's your 1, and the greater and the lesser, or what's called the indefinite dyad. When you adjust these, you find it actually in a fragment where you can actually you turn the indefinite dyad into the numerical dyad simply by subtracting these two and adding unity. So out of these, the number 2 arises. Of course, the other thing is, if you take now these, if you assume this is 1.618 and this is 0.618, again, rounded off, they're actually going to infinity, and you take the powers of this golden series, it's almost by magic. you manufacture 2, 1, 3, 4, 7, 11, 18, you get the Lucas numbers, which you find in nature not as often as Fibonacci, but I argue that they are actually more special. They're closer to divinity. They're closer to the actual functions that go on here. And so with the Binet formula, and it's common knowledge, but nobody pays any attention, the integers seem to be manufactured out of the greater and the lesser, the golden ratio in its two forms. And all numbers actually are functions of the golden mean number system. So the last thing to mention, and then we'll kind of turn it back to you, is it's easy to create a golden calipers. And the other thing that I should mention before I go on was this business about the macro and the micro. What we find in nature with the Phyllotaxis is also true, and Kepler was right, with the orbits of the planets and even their sizes. When John Martineau, the editor of the Wooden Books, wrote his little book of coincidence, he took the mean orbits of the planets and their mean diameters. And suddenly, it turned out that Kepler was right. Root 2, square root of 3, root 5, golden mean relationships galore. If you take the position of Venus over an 8-year period and you mark it off and connect up to all the dots, you get a pentagram. You get a 5-fold rosette. So the 8 years on Earth, giving this 5-fold rosette, turns out to be 13 years on Venus. 13, 8, 5, just like the microtubules, 13 filaments, 8 spiraling one way, 5 the other. The other thing is, take Mercury. If you take the mean orbit of Mercury and compare that to the mean orbit of the Earth, of course they're elliptical, but if you turn them into the mean orbits, you find that the orbit of Mercury related to the Earth is the greater squared is to 1. If you take the diameters of the two planets, the greater squared, what I would call 2.618, is to 1. Earth is to Mercury. There's a harmonics that Pythagoras had noticed, that Kepler had noticed, and just because the orbits are elliptical doesn't mean, in fact, he never gave it up, but it's there. So the other thing is, again, very simply, the canons of human proportion. Ancient Egyptians knew it. In fact, in the oldest dynasty, they used Lucas numbers. In the newer dynasty, more modern, they turned to Fibonacci. If you create a calipers, a golden calipers, where the distance between here relative to here is going to be in a golden relationship. This is my original one that I made years ago. And if you take the phalanges, say, of your finger, and you're talking about the bones now, not the flesh. And this thing is a little bit an old timer, but if I try to do it, even though there's no real points here, if I do that to the distal phalange and go to the medial phalange, I should be able to get the medial in golden ratio, roughly. If I then take the narrow part and again do the similar thing, I should be able to go from the medial phalange to the proximal. I bet this is distal here. Proximal phalange, which is the sum of the previous two. So just like Fibonacci numbers, Lucas numbers, it's additive, and each one is approximately the golden ratio times the previous. That pulse of nature, the golden modular, is true not only in the plant kingdom, the animal kingdom, the planetary, and then on, and even to the suggestion that maybe the universe itself is a Poincaré dodecahedron based upon the anomalies discovered based upon the background radiation. There are a couple of harmonics that didn't fit in. Now, I'm not saying it is, but there certainly is the suggestion that it is a possibility that the universe is itself dodecahedral, much like Plato had suggested.